So our project is dynamic refrigeration.
Pour the hot water in the cup
It all started with a design project of energy conservation.
You don't know how.
We went to a couple of different places to pick up ideas. We came across refrigeration in grocery stores. The main idea behind our refrigeration product in grocery stores is that there's a lot of wasted space at the back of a refrigerator when items are taken out, and the wall moves forward for a self-facing item, but there's all the space that's still being cooled. So now why waste so much energy cooling that back part of the fridge when the item is only at the front of the fridge? And so our idea comes around that concept. My colleague here, Factor, will explain a little bit more about the prototype.
So when we approached this problem, we had a couple of requirements that we wanted. We wanted to, one, definitely save energy. Secondly, we wanted to also have the ergonomic edge to it. So if you ever been to a grocery store, you realize, you pick up all the items, and sometimes the last item in the refrigerator is always you have to reach in. So we devised a really simple, solution that is just having a back wall that has a spring on it that pushes the items forward. So the solution we have to the energy problems with the current refrigerator system is dynamic volume modulation. So what that means is when the refrigerator doesn't have all the items in it, it shouldn't be running at its max capacity. So if there's only one item in the refrigerator, it should be designed so that the refrigerator cools only one item, or has enough energy to only cool one item. So if we look at our prototype right here, there's a microcontroller that has a sensor that senses the distance of the back wall. There's a calculation inside the microcontroller that calculates the size of the volume, and dependent on the volume, we have a certain amount of flow that we want to put into the system. Also, if you look closely on the sides, there are slit doors that help control the flow depending on the size. So now we're going to do the demo of the slit doors. Yep. So when the back wall is all the way back, you can see that it says wall position is at 3. And the coolant is coming from all 3 sides. As the wall goes forward, it turns the wall position to 2, and these 2 back slits close, and no air is coming out from the back 2 slits. As this wall keeps moving forward, the wall position is now 1, and these 2 slits also close, and only the coolant only comes from the front now, cooling the item. This saves energy, and from our calculations, we've calculated that there should be around 10% power saving. So that's really that should be really attractive to grocery store owners, and we believe that this solution can possibly revolutionize, the grocery store industry, and save a lot of energies for those owners, and reduce the price of the products that they sell.